Good afternoon, everyone. Uh, this is Robert Moyeda, and the meteorologist in charge with the National Weather Service Miami Forecast Office. And welcome to the South Florida Dry Season 2025-2026 Outlook. Excuse me. So thank you for joining us. A little bit delayed this year with the Outlook presentation. Normally we try to do this either in late October or sometime in early November, but we've had some delays. But anyways, we're glad to be able to present this, even if it's a little bit later than normal. And for those of you who have participated with us in times past, whether for the dry season or for the wet season outlook, which we normally do in May, we are once again glad to be joined by our partners at the South Florida Water Management District, as well as the U.S. Army Corps of Engineers. So I'm going to go ahead and introduce the other speakers. In addition to me, you'll be hearing from Madahel Ansar. He's the Bureau Chief of Hydrology and Hydraulics with the South Florida Water Management District. And then we also have Major Corey Bell. He's the Deputy Commander for South Florida for the U.S. Army Corps of Engineers, Jacksonville District. So we'll be presenting our portion of this outlook. And before I get started with my part of it, it's just a few housekeeping notes. What we'll do is we will each go through our presentations, and then after all three of us present, then we'll have some time at the end, hopefully about 10 minutes or so, roughly, for any questions for any questions you might have for us. So what we're going to do is we will you will be able to ask a question either by unmuting yourself and then well, first of all, raising your hand. So there's the raise hand feature down at the bottom of the screen. uh, Unmute yourself and then ask your question, or you can also put it in the questions or chat. I believe it's either questions or chat. You should be able to add, or Q&A, I believe it is. So you just put your question there, and we'll be able to answer it as well. So we'll answer the questions in the order that we receive them. So the goal is to be done by 2 o'clock. So that gives us just under an hour from right now. Okay, so I'm going to go ahead and share my screen, so the entire screen, so you can see it. So with that, I'm going to go and get started with the with National Weather Service portion of the outlook. So before we move to the actual outlook for this dry season, just want to quickly recap the rainy season. So we know these are our two primary seasons in South Florida. Though we have the rainy season, which is from May 15th to October 15th, and then the dry season from October 15th to May 15th. So those are our two seasons, and we have the outlooks that are attached to each of those. So this past rainy season, for the most part, that we ended up with below normal precipitation. The areas there in this map, courtesy of the South Florida Water Management District, of the sort of the peach or orange colors, those are areas that had for that ended up below normal for the entirety of the wet season. Areas that were a little bit above normal were around Lake Okeechobee and especially north of the lake. And even there, those were just maybe just a couple of inches above normal. So for the most part, the South Florida region received below normal rainfall, generally somewhere in the around 5, 10, 15% of below normal. That translates to anywhere from about 3 to 6 inches below normal in most areas. Now, there were a few exceptions to that, especially along the Southwest Florida coast. Primarily, or most notably, Marco Island. They actually received 7 inches above normal rainfall. And if I can move to the next slide, we actually have some point values. In other words, these are individual locations and what they received during the rainy season and what that departure from the normal is. So when we talk about the departure from normal, we're referencing a 30-year average. So again, most of the locations were below normal by a few inches, as much as 9 inches below normal, for example, in Palm Beach Gardens. And then on the other side of the coin, in Marco Island, they were almost 7 inches above normal for the rainy season. So certainly a lack of tropical systems directly affecting South Florida played a major role in this. Also, we had a pretty late start to the rainy season pattern. In fact, I don't think we really got into our rainy season pattern until June. And then we had a pretty persistent area of high pressure over the subtropical Western Atlantic, which actually extended into Florida for at least the first half of the wet season, but really even well into August, and that helped to limit the rainfall, especially along eastern areas or over eastern areas of South Florida. A little bit more rainfall again. On the west coast of South Florida, as well as the areas around Lake Okeechobee and north of the lake, as I showed in the previous slide. All right, so now let's move on to the dry season outlooks, and we're going to focus on a discussion of the different tools that we use in order to come up with the outlook and then present the actual outlook for South Florida. Since we're about a month and a half into the dry season, I figured I figured I would show where we are, where we presently stand, and we're off to a pretty dry start. Actually, quite a bit drier than normal in most areas. We've had some recent rainfall over parts of southeast Florida, as well as over parts of the central and southern Everglades. I'd say just over the last 2 to 4 days or so. But nevertheless, all areas are seeing below normal precipitation. Most notably in Southwest Florida and areas around Lake Okeechobee, where less than 30% of the normal precipitation for this time frame has been received. So we're off to a pretty dry start to the dry season, and because of that, we've had to expand our drought conditions, which normally in a quote unquote normal dry season, especially if we're coming off of a average or even an above average rainy season, we usually tend to hold off on any drought conditions until we get into, sometimes let's say usually by about February or so. But since we didn't really have a particularly wet rainy season and a dry start to the dry season, that means we've had to reintroduce and begin to actually gradually spread moderate drought conditions, extending across the entire western Florida peninsula, and now extending eastward across the Everglades and getting pretty close to the east coast of South Florida. We're still not quite in drought conditions yet along the southeast Florida coast, but as we'll show later, the expectation is that we will eventually get into some drought conditions here at some point sooner or later. So when we look at the different factors, right, that go into the dry season outlook, one of the main factors is La Nina and El Nino, and we'll talk a little bit more about that in the next slide. But just for the current state, we are in a La Nina advisory, which means that that La Nina conditions are currently in place. It started in September, and it's favored to persist through February and then transition from La Nina to what we call ENSO neutral, or a neutral condition is likely by March of next year. And another thing about this La Nina, and I'll mention it here again and over the upcoming slides, is that this episode is expected to remain weak and of shorter duration than other historical episodes. So that's something important to keep in mind here as we move along. So La Nina is part of what we call the ENSO, or the El Nino Southern Oscillation, which is an oscillation or periodic cyclical changes in sea surface temperatures in the tropical Pacific Ocean. So La Nina is the cold uh, phase of this oscillation. In other words, cooler than normal waters in the equatorial Pacific Ocean. And its counterpart, El Nino, is the warm water part of this phase, which means warmer than normal waters in the equatorial Pacific. So these oscillations, or these phases of the oscillation, the La Nina and the El Nino individually, can occur about every 3 to 7 years on average, but they can repeat from one year to the next. For example, from 2021 to 2023, we actually had 3 consecutive seasons of La Nina. These are naturally occurring phenomena that result from interactions between the ocean surface and the atmosphere over the tropical Pacific, and then those changes in the ocean temperatures can affect tropical rainfall patterns and winds across the Pacific Ocean, which in turn impact ocean temperatures, currents, and also affect weather patterns not just in the Pacific Ocean but actually over really the entire globe. So La Nina, El Nino, or ENSO is not just a Pacific Ocean phenomena. It's we it originates from changes in water temperatures in the Pacific, but its impacts are really worldwide. So what we want to see is really a coupling of those ocean temperatures, right? Those changes in the ocean temperatures with what's going on in the atmosphere above. And once we see that, when we are seeing that currently in this episode, then we can officially designate this as a La Nina episode, for example, like what we have now. This slide just shows since 1950, since we've been able to reliably track these ocean temperature changes, kind of the changes in the phase, right? So the orange areas there are indicative of warmer than normal Pacific temperatures, which is reflective of El Nino conditions, and then the blue is cooler than normal La Nina, kind of where we are now. So if you go down to the bottom slide or to that bottom graph, right there where that blue line kind of tails off, that's where we currently are. So we're slightly below normal, which means we're in a La Nina episode. And you can see that previous period from 2021 to 2023, where again an extended 3-year period of La Nina conditions, which was followed by a brief but pretty strong El Nino episode in 23, 24, and then right back to La Nina where we are now. And if you break it down by different sectors of the equatorial Pacific, so we can track it by individual slices, if you will, or sectors of the equatorial Pacific. Each of those 4 sectors that you see there in that map in the bottom left are presently in the blue, which is the right hand side of that graph. So that blue area is again indicative of cooler than normal Pacific sea surface temperatures, which again indicate that we are in a La Nina pattern. So that's where we are now. And the models or that NOAA uses to project what phase we could be in over the next year indicate that we are likely or that La Nina is favored to last, but really only last through February. So again, this is going to be a pretty short duration, or at least expected to be a short duration event. Especially by the time we get to the January, February, March 3-month period, and the February, March, April period, which is right in the middle of that right graphic there, the probabilities of La Nina go down to 30% or less. Actually, by February, March, and April, they're just under 20%. So it's highly likely, or likely at this point, that we're going to get out of La Nina sometime probably by the second half of the dry season and then get into the neutral phase, which is what means we're going to be neither above nor below normal, kind of in that middle neutral stage. And then if you look towards the end, the right side of that graphic, it actually looks like we could be, or at least the chances of the opposite phase or El Nino, the red bars begin to increase as we get towards next summer. But we'll have more on that next summer. It's still pretty far away, but we can track these even up to a year in advance, or at least what the possibilities are of what phase of ENSO we could be in. So why is La Nina important for the outlook? Well, because if we go back and look at past La Nina episodes, again, especially since 1950, we've been able to notice some fairly well-defined patterns, especially across North America. The areas where where our local weather here in Florida is most influenced by, of course. So during a typical La Nina winter, the jet stream, which is shown as that thick blue arrow in the map there at the left, the jet stream tends to be a bit farther to the north, which causes the winter storm tracks, or in other words, the tracks of the low pressure areas that will typically track west to east across the continent. for the most part, they will track well north of Florida. Doesn't mean that they always do, because and as I'll mention later, the jet stream can still fluctuate. Even if let's say, for example, the average jet stream position is farther north, it's merely that, an average. There are going to be times where it's going to dip to the south and modify some of these typical La Nina conditions. So, with a more average jet stream track farther to the north, which results in a storm track that's farther to the north, that means that these cold fronts that move into the southeast U.S. and Florida during the winter months tend to have less moisture associated with these systems. So the result of that is a tendency towards drier than normal conditions. Again, less precipitation or less moisture for these fronts to work with, therefore less precipitation. And then also that results in not as much storminess. Storminess meaning, severe weather episodes, for example, severe thunderstorms or tornadoes or even flooding episodes tend to be fewer than normal during a La Nina winter in Florida. So again, it's because of the jet stream being farther north, leading to fewer or weaker fronts into Florida, and also that can keep temperatures above normal. So fewer fronts or weaker fronts not just tend to lead to less precipitation, but also keeping our temperatures above normal or warmer than normal for longer periods. Now, this is another way of showing not just what phase of ENSO we're going to be in, but the magnitude or how strong the event could be. So we're currently in the left side of the graph there, kind of in that OND, October, November, December period. So we're just below that blue line, which means that's the delineation of what we consider to be a La Nina event. So we're expected to remain below that blue line or cooler than normal for the next few months and then start to move back up towards neutral or the zero line in the middle there, which means temperatures near normal in the Pacific Ocean by the time we get to next spring. And then, as I alluded to in a previous graph there, we could end up even trending back towards above normal by the time we get the next summer. But again, that's still far enough away that we have time to see how that might change. But at least for the dry season, again, La Nina conditions, but on the weaker side, not a very strong, well-defined event, and then gradually getting back into neutral conditions by the second half of the dry season. So a weak La Nina, which is what it looks like this will end up being, would be less likely to result in these conventional winter impacts that I just described previously. And we're going to get into more detail here coming up in the next several slides. So we talked about the ENSO phase. So the other factors we look at are long-term or longer-term climate trends, for example, the last 10 years of temperatures and the last 15 years of precipitation. And then we also look at dynamical and statistical models to give us a sense of where we could be trending over the next several months. So when we look at the La Nina, or what we have seen as far as temperatures and precipitation in past La Nina episodes, and then combine that with trends for temperature, for example, as we're seeing here, what we end up seeing is across Florida is a trend of warmer or warmer than normal, right? So the average departure is for above normal or warmer than normal temperatures, and then with about a 30 to 50% frequency of that occurring during these La Nina events. So that's what the right graphic is showing. So the bottom line is here, La Nina, based on past events combined with trends, leans us towards warmer than normal winters and really dry season overall. So if we just look at the last 10 years of temperatures, and which is concentrated in the right side of this graph, right there where I have that circle. This is for Florida Climate Division 6, which is the interior and southwest part of Florida, but this is representative of all, really even extending well up into the central, even northern part of the Florida Peninsula. So I just use one just to illustrate the example here. So the trend, certainly over the last 10 years, has been for above normal temperatures. So the mean line is that kind of that grayish line there. So the last 10 years of winters have been well above normal for the most part across much of the Florida Peninsula. In fact, at least in South Florida, the last cooler than normal winter was 20, I believe it was 2010, 2011. So it's been quite a while since we've had a cooler than normal winter. And in fact, 4 of the 30 warmest winters on record in South Florida occurred during weak La Nina episodes, not too different from this one, after the year 2000. Now, switching over to precipitation, the trend here, well, when we take a combination of the previous or past La Nina winters plus trends, we're looking at a pretty strong signal for below normal. I'm sorry, for below normal precipitation or drier than normal. And those have occurred actually with a pretty high frequency of 70 to 90% of drier than normal conditions during La Nina winters across South Florida. And looking more specifically at values across the South Florida Water Management District area. So this is an average from the South Florida Water Management District areas, which is most of South Florida and even parts of Central Florida. Uh, all but one dry season has had below normal precipitation during the last 8 week La Nina. So basically, we looked since 1995. We looked at the last 8 week La Nina episodes, similar to what we're expected to experience this dry season. And the only one that had above normal precipitation was 1995, 1996. So again, this gives us a little bit more confidence based on trends and based off past La Nina events of below normal precipitation. Now, if you just look at trends alone over the last 15 years, again, regardless of what ENSO phase we were in, there it's actually more mixed because we've had some above normal precipitation winters, especially with the El Nino episodes that we've had over the last 10, 15 years. But so if we just look at trends alone, that's not going to tell you the whole story. But it is one of the things that we factor in, especially when these trends are combined with with past La Nina episodes to give us an idea of what we could expect for this current La Nina episode. And in fact, three of the 30 driest December to April periods on record occurred during weak La Nina episodes after 2000. But I had to throw this in here because that's a bit of a caveat. Two of the 30 wettest also occurred during post 2000 weak La Nina episodes. So it's not a guarantee that we're going to be drier than normal. In fact, those two were exceptions where we had pretty wet winters despite the weak La Nina pattern. Okay, and finally, the last factor that we look at are seasonal models or the statistical dynamical models. So for temperature, these are the latest outlooks for the next really for December, January, February combined, showing pretty strong signals not just over Florida but over a good part of the United States for above normal temperatures. That's what we're seeing in that left map, with about a 70 to 80% chance of occurrence. And for February and April, these model probabilities are similar. So I'm just showing the December, January, February to give you an idea of what it looks like for the entire dry season as far as the models are concerned. And for precipitation, certainly a lean towards drier than normal. As you see on the left-hand side, those reds and oranges across Florida are indicative of drier than normal. But the probabilities here actually are not as high. So if we go back to the temperatures, there was 70 to 80% chance of above normal, according to the models. But for precipitation, it's really only about 40 to 50% chance of drier than normal. And in fact, even across far southeast Florida, it's actually somewhere closer to 40%. So still leaning below normal, which is consistent with all the other things that we've looked at, but maybe with not as high of a level of confidence. And again, these are based on models that are actually taking current conditions and then projecting changes out here over the next several months. So we'll hone in on the South Florida outlook here coming up here shortly. But before that, I want to show again some of the impacts that a drier than normal and warmer than normal winter could lead to. So, one of the things that we typically see during a La Nina winter and dry season are fewer tornadoes. So this is for the South Florida area. So if we just look at the weak La Ninas, which is the inside that box that I just put on the screen, the number of tornadoes per season is fewer than what we would see during a El Nino winter, which is what you see over on the right side. Uh, similar trend for severe thunderstorm winds, or these are winds of 58 miles an hour or greater that have occurred across local areas. And again, for La Nina events, that we tend to get fewer of those as opposed to, for example, during El Nino winters when we have a significantly higher number of severe wind reports. And finally, for heavy rainfall, so these are number of days, average number of days with 3 inches of more of rain per observing site. So these are observing sites that we keep track of, and we counted the number of days in which those observing sites reported at least 3 inches of rainfall. And as you would expect, based on the last few slides, there are fewer of those on average during a weak La Nina compared to, for example, a strong El Nino on the right side there, where you have it's as much as two or greater than two times, or two times more, or 2 times greater number of days with 3 inches or more rainfall. Now, and you're going to hear me say this a few more times, there are exceptions. And we have to always keep that in mind because we're talking about a seasonal outlook that's not just a week or so or 2 weeks. This is a 5 month overall period. Or actually, it's really a 7 month period if you go back to the beginning of the dry season in October. So these exceptions more recently is 2023. So 2023, in April of 23, to be more precise, we were wrapping up the that last La Nina episode, and we actually ended up with a couple of significant weather events in South Florida. One of them was this EF2 tornado that affected the Palm Beach Gardens area, associated, with a pretty strong low pressure area and frontal system. So again, a La Nina episode, but we ended up with a pretty significant tornado event, at least for this area here. This and also, if we go back to the 2016-2017 La Nina episode, there were 3 tornadoes reported during that dry season. So the key point here is that singular events and singular significant events can occur in any season during any ENSO state. Another exception from the same year, 2023, was the severe Fort Lauderdale flooding of which occurred on April 12th of 23. So again, just a reminder that even in an overall, if we take the average for that dry season, it was below normal and not as stormy. But in April, it changes in the weather pattern, more or shorter scale. What changes led to some significant events. So we always have to keep that in mind. Okay, so let's go now and I'm going to show now the official NOAA outlook. So this is the precipitation outlook for December, January, February, so the winter months. And for Florida, at least for central and for most of central and all of South Florida, we are calling for or we're calling leaning below normal. So if you look down there at that the legend in the lower right, it's up to about a 40% chance of below normal precipitation during the winter. And actually, the February to April outlook, which I'm not going to show here, but it's almost exactly the same as what you're seeing here. Switching over to temperature, it's a higher likelihood of above normal. So this is for December, January, February, showing a 50 to 60% chance of above normal temperatures across central and South Florida, and a little bit lower in the January to March timeframe, which I'm not showing here, but the January to March timeframe is in the 40 to 50 range, but still certainly favoring above normal temperatures. So we're going to get more specific for South Florida here in a second. So one thing to remember is La Nina or El Nino, but in this case, for this dry season, we'll be talking about La Nina. La Nina sets the stage. So it's not a direct cause of any particular weather event, or even whether we end up below normal precipitation or above normal temperatures. It's not strictly because of La Nina, but La Nina helps to set the stage via some of the changes in the weather patterns that I described earlier that lead to those conditions occurring. Because so the ENSO relationship, or the relationship between La Nina and local weather, is not a simple one-to-one relationship. There are other factors that come into play, other oscillations or phases that can influence or even dominate for periods of time, usually on a shorter time frame. And we're not going to get into these in any detail, but we have we look at oscillations such as the North Atlantic oscillation, the Arctic oscillation, uh, Pacific North American pattern, and also the Madden-Julian oscillation. So these are on shorter time frames that when they occur, regardless of what phase of ENSO we're in, they can modulate. They can either enhance or act in opposition to the overall ENSO phase. And it's during those times is when we can see fairly significant departures from the average. So that's why when we express these outlooks, that's the reason why we express them in probabilities, right? So the outlooks show the most likely outcome, but it's not the only possible outcome. So, for example, I just showed that we have a 60% chance of above normal temperatures. So, what that means is that not only is there a 60% chance of above normal temperatures, it also means there's a 33.3% chance of near normal temperatures, or about 1 in 3, and a only 6.7% chance of below normal temperatures. So that near normal is not negligible. That's about 1 in 3. A 50% chance, again, 50% chance below normal means that there's also a 33.3% chance of near normal, and a higher chance, 16.7 or 1 in 6, chance of above normal precipitation. So that's one good way to look at this. It's just because we're saying uh, that the outlook favors above normal temperatures, for example, doesn't mean that it's a slam dunk. Not in any sense of the word. So this is the summary of the South Florida dry season outlook. So kind of what I've already showed, and then just kind of bringing it down more on a local scale. So temperature, again, the most likely outcome will be above normal, with about a probable range of 1 to 3 degrees Fahrenheit above normal. For precipitation, somewhere probably in the 10 to 30% below normal range, which does tie into a below normal number of storminess, or storm events, or storm episodes. Freeze, we're still calling it near normal. Typically in a South Florida winter, we get one or maybe two freeze events, generally around Lake Okeechobee and those interior, typically colder areas. So we don't see any reason to really depart much from the normal, even if we're calling for overall above normal conditions, due to the fact that it just takes one or two significant deviations from the normal pattern to get cold air intrusions deep into Florida during the winter. And then, now, last but certainly not least, and this is going to be one of the primary concerns for us this dry season, will be drought and wildfire. So we're already in drought conditions, as I showed earlier, and with the expectation of below normal precipitation, that means that it's more than likely that the drought conditions will at least persist or even worsen during, as we go through the dry season, which could lead to the wildfire threat increasing perhaps as early as January, and certainly by the second half of the dry season, when our wildfire season really peaks here in South Florida. So this is just kind of the same thing I just talked about, but kind of assigning confidence levels to it. So we're a bit more confident with the temperature outlook uh, than the precipitation outlook. But even for the precipitation outlook, we have a moderate level of confidence. Again, the combination of the weak La Nina plus the models, the confidence is tempered somewhat because of the fact that it is a weaker La Nina, and also, as I showed in the graphic of the models, there's an indication that some of those chances of below normal precipitation this dry season might even be a little bit lower, maybe close to like 40% across far southeast Florida, which opens the door for some of the other for even a near normal uh, precipitation season being a bit higher, maybe not too far from 40%. But for the temperatures, our confidence is a bit higher again due to more agreement between the La Nina trends or the past La Ninas, the trends, and the models. And certainly, again, I want to emphasize the above normal chance of moderate or worse drought conditions that are not just present at this time, but also spreading and even or getting worse, which again leading to or resulting in above normal wildfire potential, especially by January. So our confidence is actually pretty high that we're going to see drought conditions spread or maybe deteriorate. And that could also lead to, again, our wildfire potential increasing as early as January. So these outlooks are, just that. And I threw the definition here from Merriam-Webster: a general big picture view of a set of conditions that will probably exist in the future. So it's not well, the bottom line here is that it's not a certainty. Right? These are longer range outlooks. So, it's one thing is to give you a daily or weekly weather forecast, which have typically higher levels of confidence for the most part. But when we're extending the time frame to several months, then we have to be more general. And we're more general because these outlooks are associated with large degrees of uncertainty and are reflecting average conditions over the entire season, not necessarily not representative of what is expected on any given day, because what we get on any given day is dependent on where exactly the weather features are at that point in time, not on average over let's say a 2, 3, or 4 month period. So these are usually good for general planning and overall awareness, not to anticipate what the weather is going to be, for example, on January 14th, right? Or just pick any other day during the upcoming few months. So these potential impacts that we typically see during La Nina, which we have to keep an eye on, are again these extended dry periods, which can lead to drought conditions, which could affect water supply, but also wildfires as well, especially once we get to later on in the dry season, as well as fewer Arctic air intrusions. But these longer warm periods could make crops more sensitive to cold or to cold outbreaks that can still occur, even if it's just one or two a season. And then we also look at, for example, rip currents, which rip currents occur during much of the year along our coastlines and our beaches, but we do tend to get them mainly in November, sometimes even into December, and then again once we get to the spring. And there are the other time frames, the more favored time frames for freezes, which is the winter months, severe weather, more favored for the second half of the dry season. And as we've mentioned before, wildfires and drought tend to peak in the February to May timeframe. Okay, well, that concludes my part of the outlook. So I'm going to go ahead and stop sharing my screen. And what I will do here is I will now go over to Madahal Ansar, and when he's ready, he's going to go ahead and give you the outlook from the South Florida Water Management District's perspective. So Madahal, we'll take it away when you're ready.
All right. Great, Robert. Thank you. Can you see my screen?
Yes, I can.
Okay. All right. So I'm going to give you a briefing on basically how we are transitioning to the dry season in terms of water management and what we're seeing in our various water bodies and some of the projection on LACO as well. I'm going to start with the weather. Some of this maybe it repeats from what Robert shows. This one is basically a slide showing the monthly rainfall starting from last dry season, the 2024-2025 dry season, all the way to the present. The light blue is basically the amount of rainfall that has fallen in a given month, and then anytime you see a red there, it's showing a deficit for that month. When you see a dark blue, it's a surplus. You can see that the 2024-2025 dry season, almost every single one of those months had a deficit, and that led to a much below normal rainfall for that dry season. We got about 57% of normal, and then working my way towards the past wet season, basically was showing near normal for the entire wet season. What happened was May was above normal by about 1.37 inches, and then that was balanced by a deficit in the month of June. And then the rest of the wet season essentially was pretty much normal, very close to normal, either slightly above it or below it. In the end, again, we ended up with a normal wet season as far as rainfall. And then as Robert mentioned, we're starting pretty dry for this dry season. And I'll show some of the graphic, somewhat repeating what he was showing. First to the left, this is just looking at basin by basin. As Robert mentioned, I think he showed this slide before. District-wide, we were showing 100%, close to 100%, basically showing normal rainfall for the wet season. But if you break it by basin, you see quickly that north of the lake, predominantly most of those basins are slightly above normal, and the ones south of the lake are slightly below normal, with the exception of maybe Broward that was showing close to 90% of normal. The rest of them are pretty close to normal. But then when you look at the dry season, which is the graphic to your right, you see a lot of red there, just showing that we're starting this dry season super dry, about 35% of normal so far. Again, predominantly the basin north of the lake are the ones that are showing the highest anomalies, with Lower Kissimmee, for example, and Lake Okeechobee Basin showing close to 17, 16% of normal. So that's just showing that we had a super dry November, and hopefully December will bring better news. But with La Nina condition being out there, we're still expecting below normal, at least till we get to maybe March, April timeframe. Now I'm going to switch to water levels, working my way from the northern part of the system by Upper Kissimmee area near the city of Kissimmee and St. Cloud. You see that, oh, sorry about that. For some reason, this thing is, excuse me, I just need to minimize this. You see the regulation schedule, which are the red line, and then you see the traces, which are the stages that we are measuring within the lake. Those are shown in blue and green. Essentially, what the regulation schedule does is it give us a sense of what kind of operation we need to be doing for that lake. When we are above the red line, we're typically doing flood operation. And then when we are below that red line, we are doing either water supply releases or we're doing ecological releases from that water body. And normally the regulation schedule will reach a minimum around the beginning of a wet season, and then you reach a peak by the start of a dry season, what we call the winter pool. So in an ideal scenario, you get your lakes fully replenished by the time the dry season starts. And you're seeing that in many of our lakes. For example, this is East Toho, is showing that it's basically at schedule, meaning the green and blue line are matching that red line at the winter pool level. And the same thing is happening for Lake Toho as well. And then when you move towards Lake Kissimmee, you're seeing that we are not at winter pool. That's because for Lake Kissimmee, we're doing what's called increment one operation. Essentially, it's an operation that we are doing towards the full headwater revitalization schedule. We take Lake Kissimmee, Hodgena, and Cypress, these three lakes, to higher levels compared to what was done previously. The intent of that is, again, is to restore the littoral zone of those lakes, as well as restore the Kissimmee River downstream. So we're making some releases out of Lake Kissimmee to provide water to the floodplain for the river. Because of that, the water levels in Lake Kissimmee are much lower than the winter pool. It does not mean things are not where they need to be. It just means a different special type of operation we're doing in that lake this winter, again, to start some of this restoration effort on Kissimmee River. Working my way towards the south, Lake Istopoga, which is just northwest of Lake Okeechobee. You can see that the water levels are declining, but they're still in that zone B, essentially that water supply zones, where we're making some releases out of outlet structure there. I think there's two structures, S68 and S68X. We use those to make water supply releases to provide water to the Indian Prairie Basin and some of the basins that are downstream of Lake Istopoga. And Lake Okeechobee is at 1367 today. I think this is a slide that's from a few days ago, but it hasn't really changed a whole lot. Today is at 1367 NGVD compared to 1366 when this slide was prepared. So that trace is shown in black here. The lake is in much better shape than it was a couple of months ago because we're in Zone D, and we try to obviously stay in that Zone D as much as we can because when you are below Zone D, you are in what's called the water shortage management band. That's really when we are more or less in a hydrological drought, and things get a lot tighter when we are in that yellow zone. So right now we are in Zone D, and because of that, water supply-wise, we're still in good shape. Obviously, we're watching that carefully because it's still on the low end of the spectrum. Historically, if you compare where the lake is today versus what it is historically for this time of the year, it's around the 25 percentile. And I'll show some of the projections that show potentially we could get into that water shortage management band. There is some likelihood of that happening, and I'll show that in the next slide in a second. So that's the slide that kind of shows us projection. What we do here is we take our regional models, and then we use those models, we run them using basically historical rainfall and using current operation from the lake and then current infrastructure that we have in place. And that gives us a series of model runs and results, and those model results are used to generate statistics like what you're seeing here. And those statistics are actually also additionally conditioned with the climatological forecast, meaning when Roberts and others from the National Hurricane Center give us information like La Nina condition being out there, those are also baked into this projection. So it's not just equal chance for all the years that have trends that are similar to this year, obviously will have a higher weight. So in a sense, it's a forecast that is again conditioned by the climatological forecast, and you end up with a series of lines like this that give you percentiles of where the lake may end up. Normally, we pay a lot of attention to what is between the 25 percentile and the 75 percentile line. Zooming in on the 50 percentile, you can see if we just look at that 50 percentile, there's that 50 percentile likelihood of being in Zone D throughout up to next wet season. There is still, like I mentioned, a likelihood of us falling into the water shortage management band is showing about 25 percentile chance of getting into the water shortage management band in May sometime mid-May or so next year. There is even a smaller chance we could get into that water shortage management band a lot earlier than that, less than 5% chance. That could happen sometime in March, maybe mid-March or so. So again, these are projections that help us fine-tune some of our strategies and how we operate the system as we progress through the dry season. Now, working my way south, so for LECO, again, the Corps does most of the operation for discharges out of Caloosahatchee as well as St. Lucie, and Major Bell will get into some of that. We do have structures south of the lake that we use for water supply releases. Right now, we're doing some water supply releases in some of these canals, Miami, Hillsborough, and North New River. I think about 1,100 CFS we're sending south, essentially water supply to the EAA. Lake Okeechobee is in Zone D of LOSAM. That basically mean in terms of release guidance that we call for no releases out of S80 up to 300 CFS at S352, 2,000 CFS at S79, and up to 1,100 at S351 and S354. Again, those are up to value, meaning the Corps could elect to go up to those numbers, but that does not necessarily mean they always go to up to those numbers. A lot of things are factored in, including the forecast, the climatological forecast, as well as some of the things that are happening system-wide before making a decision on specifically how much those releases should be. WCA1 is below schedule, WCA2A is above schedule, and then WCA3A is slightly below schedule. And right now we're making water supply releases on and off out of the WCAs to the East Coast as needed. The S10, which are the structure between WCA1 and WCA2, are closed, and the S11, those are structure between WCA2A and 3A, are closed. And then making releases out of 3A in accordance to the water control plan there. We follow what's called the Tamiami Trail flow formula. It calls for about 822 CFS to be released, and those are subdivided between the discharge structure S12D and then S333 and S333, and doing about 250 CFS at S12D and then 600 CFS at the S33333, and that's water that's again meant to go into the park, Everglades National Park, downstream, in line with what the water control plan called for. A number of other structures are closed at 343A and B, 344. Those are structured to the west in 3A. There are some releases out of S144, 145, 146. That's just to send some water out of 3A into 3B. 3B is a little bit on the low side now, so some releases are being made at those structures to compensate for that. And then S176, S177 are closed. S18C, that's on C111, and S197, those are closed as well. 8.5 square mile area is in good shape. LPG2 stage is below ground, and 357 is pumping as needed to maintain stages. And the pumps at S199, S200 are pumping as needed to maintain the stage within the ranges. Now, this slide talks about groundwater. Again, beyond just looking at what's happening in our water bodies, we obviously monitor what's happening in our aquifer system. And what I'm showing here on the left is basically the rainfall, just to reiterate that so far in the dry season, we had well below normal type of rainfall, close to 30%, 31% since November 2nd through December 1st. That obviously translates into some impact in terms of what it may mean for some of the groundwater well. But broadly speaking, north of the lake, you're seeing a lot of green and then some blue near upper East Coast. Those are typically wells that are in pretty good shape, meaning they are in either the 25 to 75 percentile or the 76 to 90 percentile. We do see some red, mainly in the interior basin in Broward and Miami-Dade. Some of these are close to some cutoff wall here that kind of impacts the superficial aquifer, so that's why they're popping up as red. On the West Coast, for this time of the year, it's not unusual to see some red there, mainly because we have different aquifer system on the West Coast, and some of those aquifers are pretty deep, and it takes a while from the previous wet season to actually make its way into those aquifer systems that are much deeper. So you see some of that red mainly because of much deeper aquifer. In fact, some of that water may not even come from our district. Sometimes some of that surface water come from SwiftMud and work its way into those wells. As far as what we are doing specifically when we doing this transition, obviously we check and test forward pumps. Those are pumps that we use for getting water out of a lake. When Lake Okeechobee get too low at times, we are not able to pull water out of the lake by gravity, so we have to rely on actual pumps that are installed out there. They're temporary, and then we test those and check them so they are ready to go if need be. Hopefully we won't need them, but if we do need them, we are ready to make that happen. We schedule maintenance and upgrade activities, which switch already from flood control operation to water conserving strategy, water supply type of operation. Example of that is we switch our canal operation to what's called high range, meaning you raise the canal system higher than what you would typically do during the wet season. And by doing that, you help recharge the nearby aquifer system. We promote flows to keep our STAs hydrated. We promote flows to coastal canal to maintain groundwater levels and limit saltwater intrusion. Obviously, we keep track of rainfall and projection to help us strategize throughout the dry season. And we focus on managing water that we have in storage to last us throughout the dry season while satisfying the system need. As far as outlook, again, and what's happening on the ground, Upper Kissimmee, all the lakes are at their respective winter pool. Lake Kissimmee is in Zone B3, in line with Kissimmee River Increment 1 deviation. As I mentioned, those are operations that are meant to help restore the floodplain of the Kissimmee River. Lake Okeechobee stages within the lower portion of Zone D and is projected to remain that Zone D for the next 2 months. With WCA1 is about at the 50 percentile below schedule by about half foot. 2A is in great shape, about 1.8 feet above schedule, close to about the 75 percentile for this time of the year. And WCA3A is below schedule at 1.1 foot below schedule and close to, I think, around the 25 percentile for this time of the year. 1 and 2A are both near and above their seasonal median level. And 3, I already mentioned, that's pretty low for this time of the year. And the system is operating in its higher operating ranges to conserve water, essentially holding water where we need to and then make water supply releases where we have to. And the central region remains stable and operational for water supply. Most of Palm Beach coastal sites are in high range to conserve water with small discharges to tide. And that's what I have as far as update on the water management system.
All right, thank you, Madahel. Yeah, and we will hold off on questions here for another couple minutes. We already have a couple that I see, but before we get to those, let's go now to Major Bell from the U.S. Army Corps of Engineers, and I know he has a few talking points that he wants to share with us here. So, Major Bell, whenever you're ready, the floor is yours.
Awesome. Thank you so much. Thank you for having me today and joining the team. So currently, Lake Okeechobee is at 13.67 feet, as discussed earlier. So we're within Zone D of the Lake Okeechobee System Operating Manual, LOSOM. And it's pretty low for this time of year. We're still targeting a 350 CFS release at S79 and water supply releases as required. WCA Water Conservation Area 1 and 3 are slightly below schedule, and we're monitoring those. And 2A is above schedule and making releases, and we have no concerns with that impoundment area. The water levels throughout the entire region of the CNSF, to include Kissimmee, Lake Okeechobee, and WCAs, are still a little low this time of year typically, but thankfully we've had no tropical cyclone events, hurricane events that we have to contend with that would impact our operations. And what this water level, low water level means for us overall is we've got to balance our project needs from a water supply and environmental concerns. So, we're taking all these into account when we discuss operations. But we did conduct what's called Lake Okeechobee Recovery Operations, LORO, which ended in May. This has already seen great improvements for the lake ecology itself, where we increased the subaquatic vegetation, that's SAV, from 4,000 to 28,000 acres. So that's a great improvement. It creates a healthy lake, which creates a healthy environment and cleaner water to head to the Everglades. We released a news release this afternoon for the Active Action Report. And this is the AAR process that we're asking feedback from all participants, state, federal, tribal, and communities, to provide feedback on the impacts of our operations so we can better refine our operations moving forward. And the Jacksonville District is, following the lapse of appropriations, we've been, surging back into action, actively engaging our partners, stakeholders across a range of portfolios and programs that we manage here in the Jacksonville District. This week alone, I've already presented at Martin County Board of County Commissioners, and we'll be hosting a Lake O media call this Friday. The Colonel Bowman will be presenting to the media on Friday. And we've continued to work with South Florida Water Management District, where this week we conducted our dry season assessment midpoint, where we garner input from, again, our federal, tribal, state, and local governments, and public comment for this one as well. and we're looking to formalize that strategy moving forward. Once we can present that to the commander, and then we'll move forward. But we're happy to be here and happy to take any questions, and I'll pass it back to you, sir.
All right, thank you very much, Major Bell. Appreciate your talking points there, as Matahel, as well as your information as well. So, before I address the questions really quick, we are going to, or this is being recorded, and we are going to provide the link. It's going to be on the South Florida Water Management District's YouTube page. So we'll provide the link for that shortly after the end of the of this meeting. Okay, so we have a couple of questions, and also a reminder on questions. If you have any questions, you can raise your hand, and we'll make sure that you can unmute yourself, or you could also type it in the Q&A box there at the bottom. So we have one question, first question from Kim Miller of the Palm Beach Post. She's asking, what happens if Lake Okeechobee goes into the water shortage management ban? And I think maybe this was addressed. I think it may have been, but anyway, either Matahel or Major Bell, if you want to take that one.
Sure,
Yeah,
I don't mind taking it.
Go ahead, yeah.
So sorry about that, Mr. Anzer. So what had happened is our authorities kind of changed. We rely on South Florida's input a lot greatly on that, because it becomes a water supply, which is their, one of their tasks they have to do for the state. And I'll pass it off to South Florida to answer the rest. Over.
Yeah, thank you for that. Yeah, so when we get into the water shortage management ban, like Major Bell mentioned, the authorities shift to the state, and then at that point, we do what's called supply side management. So we have a Lake Okeechobee supply side management plan that we follow. It get into, again, water conservation. It get into potentially water restriction, just depending on the severity on the drought and how bad things get. Hopefully, we don't get to that level, but it just means the states take over in terms of operation of Lake Okeechobee, and we just have to keep track of our water supply obligation and make sure that the water is appropriately managed to meet the permittees' needs. But at the same time, we have a specific plan that we follow, and it trigger that emergency plan, and then we just follow that. Over.
Okay, thank you very much. Like I said before, if you have any questions, you can either raise your hand, and we'll ask you to identify yourself. We'll make sure you're unmuted, or you can unmute yourself and then you identify yourself, or you can type it into the Q&A as well. We have another question. This is from Andrew at Fox 4. He's asking, well, it's kind of a long question. I don't know. Hopefully you can see it, either Matahel or Major Bell. It's related to the Caloosahatchee River and C-43. Can either of you see the question?
Yes, sir. So I can talk to some of that, and I'll pass it off to Mattel to talk about C-43 operations. But when we're looking at the MFL, it's over a 30-day average. So I don't know if that really helps Mr. Shipley on that or not, but that's kind of how we look at that. Is it's a 30-day moving average through that structure, and I can pass it off to South Florida to answer C-43 questions. Over.
Yeah, so yeah, with C-43 reservoir, as you said, is not ready yet. In terms of the MFL violation, yeah, there are discussion about that. I know in some of the internal discussion that was mentioned, it was brought up. But like Major Bell said, it's a 30-day average. I believe it's 450 CFS. Some folks were calling up to 750 CFS. That's 79. I believe the court is doing 350 there. As much as we're hearing about the MFL violation on Caloosahatchee, we are also hearing from others saying you need to conserve water on the lake because there is still a likelihood of being in that water shortage management ban. So broadly speaking, system-wide, there are obviously competing things that need to be looked at, and discussion are happening between our two agencies and to make the appropriate decision. But that is something that's on our radar screen. We are aware of it. The court is aware of it, but I don't know if the violation has happened yet or we're getting close to it. But what I do want to stress is that's one side of a coin. There is also others that are calling for us to conserve water on the lake. So it's not an easy thing to do. It comes down to balancing the different objective of this complex project. Over.
All right. And Kim from Palm Beach Post has a follow-up question. Should we use NAVD88 or NGVD29 when we look at Lake O levels? I think the answer is NAVD88, but I will let Matahel answer that question officially.
Yeah, so for all practical purposes, we have transitioned to NAVD88. So we're still reporting on NGVD29 at time, just so people can refer back to things. But all our sensors have all been surveyed and calibrated in NAVD88. So the number you're seeing really officially come from the field as NAVD88. We just report them back sometime in NGVD29 because people are very comfortable and very used to NGVD29. But really, for all practical purposes, we are an NAVD88. Over.
All right. Thank you, Matahel. Yeah, thanks for clarifying that. Okay, I don't see any questions right now, either on the chat window or anyone raising their hands. So we'll give one more opportunity for that. While we give that opportunity, I want to make sure that I thank the folks at the South Florida Water Management District, that not just Matahel and his team, but also those behind the scenes who help set up the Zoom session, are doing the recording, and we'll make this recording available for everyone. So I appreciate all, as always, your work in making this a successful meeting and presentation. And I also want to thank the folks at the U.S. Army Corps of Engineers Jacksonville District, who have more recently, in the last couple of years, have gotten more involved in these outlooks, and we really appreciate their input. As you heard Major Bell and his talking points, they're a critical part of the water management structure here in South Florida. So we appreciate their collaboration and their participation as well. Okay, I don't see any questions, so I think we're going to go ahead and wrap it up. So thank you all very much for participating. I think we had a pretty good turnout. I didn't see the exact numbers as I was presenting, but I think it looks like we had a good turnout. We will provide the slides and a summary, and also the link with the YouTube or the link to the YouTube recording from the South Florida Water Management District. So stand by for that via email. And if you have any questions, you can always reach out to me or any of the folks that are here that were presenting. So once again, on behalf of everyone here, I thank you once again and have a great rest of your day. Take care.